So, here's what L'Hopital's rule says.
L'Hopital.
L'Hopital.
That'd be such a cool name. I'm gonna name my child that.
Yeah, you're gonna name your child the hospital?
Yeah.
Alright.
Because he's gonna be sending people there because he's gonna go straight to G.
His brother's gonna be like North South. Other one's grading them more.
Whoa. Quotient rule.
Alright, here's what L'Hopital's rule says. If you have a limit as x approaches a number, and it can be infinity, it could be 5, it could be any number that you want. If you have a limit as x approaches a number, and you plug in, and you get either 0 over 0, or infinity over infinity, plus or minus, right? It can be positive or negative, the sign doesn't matter. Any infinity over any infinity, then you can take the derivative of the top and the derivative of the bottom and have an equivalent limit. Alright? So remember, derivatives make functions simpler, right? You go from a cubic to a quadratic, right? You always reduce that power. So more often than not, derivatives make the function simpler, and what happens is they make the limits simpler, usually, and then you can plug in and have an easier limit to use, right? Okay, so quick example before we get, just to start us off before we get into the more difficult examples.
Why is school so cold?
Perhaps because the AC is on.
I'm surprised you should turn off your AC.
Are you chilly?
Yeah.
Very chilly. Very chilly.
You know what, Nelson?
I might catch a cold.
It's not all about you. I might be very hot right now.
You're not, Mustafa.
All right. So we're just going to start with a simple limit just to see what happens. Now, whenever you have a limit, what's the first thing you're supposed to do? Very first thing, no matter what. Plug in, right? So if we plug the negative 3 in, we get 9 minus 24 plus 15. Does anyone know what that equals? 0. It's 0. Over 9 minus 9, which is 0. Now, in the past, what would you have had to have done to do this limit?
Factor.
Factor, right? Let's just pretend that you are the worst factorer in the whole world.
We don't have to.
Okay? Okay. Yes. So you couldn't factor yourself out of a paper bag, right? So you are like, oh my gosh, what am I going to do? I don't know how to factor. Thank goodness I have L'Hopital, right?
Thank you.
Okay. So if I plug in and I get 0 over 0, I can take the derivative of the top, which is what?
2x plus
And the derivative of the bottom, which is?
2x.
2x. And now, if I plug my negative 3 in, on top, I get negative 6 plus 8, which is? Over on the bottom, I get? Negative 6. And my limit is negative 1/3, and I'm done.
I'm going to tell the kids next year about L'Hopital's rule. They'll never have to suffer.
But they have to be able to do derivatives.
Derivatives are
Too bad.
Okay.
Have my own class.
All right. Now, if you want to verify, should we verify real quick? Make sure that I didn't mess up the math.
Well, I trust you.
Can you do higher order derivatives too? Like, say if you were to have like
Let's see here.
explained
Oh, wait. No, this has to be a minus for this to factor, right?
Because there's no, like,
Let's see, this is different.
No, it's good.
Oh, it's x plus 3, x plus 5. Duh.
So she is the world's worst.
I am the world's worst factorer. Okay, so cancel. Now we plug in our -3 and we get -3 plus 5, which is 2, -3 minus 3, -6. Oh, look at that. Right? Well, it's a good thing I had L'Hopital because I stunk at factoring, right?
True that.
Yeah, true that. All right, so good. So what we're going to do now is we're going to do some examples just to get you familiar with how it works and when you can and can't use it. So as a premise, it's really pretty easy, right? You plug in, you get 0 over 0. You can take the derivative of the top and the bottom. No quotient rule. Just derivative of the top, derivative of the bottom, two separate derivatives. And you have an equivalent limit, right? Okay, so what I want you guys to do, let's go back to some limits that you may or may not have enjoyed.
I didn't enjoy it, for being honest. Limits were a dark time.
Limits were a dark time. Alright, so for this one, back in the olden days of August, what would you have needed to
Factor.
multiply top and bottom by the conjugate of the numerator, right? Okay. And then multiply it out, and then you're going to have to clean it up, cancel common factors, right, and then plug in and solve. So for this one now, let's try doing L'Hopital. If we plug in the 0, we get what over what? 0 over 0, so we can use L'Hopital. And everyone's take a minute and just find the derivative of the top and the derivative of the bottom. Make sure you rewrite your limit statements. These are limits.
Let's see. Derivative.
Bam.
Bam.
Boom goes the dynamite. You know when you push against your eyes and like you see the white lights and stuff? You know what that's called?
No.
It's called a prisoner's cinema. Because that's all what prisoners can watch when they're so alone crying.
All right.
It's like, you push really hard, it's like really bright, but then it also ruins your eyes, so it's kind of a trade-off.
Okay, in order to do the top derivative, I would have to rewrite this x plus 1 as x plus 1 to what power?
1/2.
1/2, right? So my derivative, I get 1/2 times x plus 1 to the negative 1/2
Times x.
times, what's the derivative of the inside? 1, right? What's the derivative of 1? 0 over, what's the derivative of x? 1.
And then you want to...
Let's clean it up. So we end up with 1 on top over 2 root x plus 1 on the bottom. We plug in the 0, and what's the limit?
1/2.
1/2.
Is that the chain?
Yeah, that is chain rule.
This is chain rule. Yes, this was chain rule.
So you're going to also have to teach your kids chain rule. Would you ever have to do quotient rule with this? Like if it's
Yeah, well,
like a fraction?
a fraction within like a complex fraction.
Yeah.
It's not very often that we give complex fractions, except, oh my goodness, how about this one? Okay.
Yeah, that's probably what it is. She probably wrote it on her answer key as soon as I asked.
Alright, you still don't need a quotient rule though. Alright, rather than using quotient rule, I know how much you guys loved these limits, right? The complex fraction limits. So rather than using quotient rule for 5x plus 2, could I rewrite the 5x plus 2 to a power?
Yeah.
What would it be? 5x plus 2 to the negative first. Alright, everyone take a second to try that derivative, right? Can you rewrite chain rule on the board, please? The chain rule? Sure. Chain rule.
Does that equal 0, 0 also?
Says the derivative of f of g of x equals f prime of g of x times g prime of x. So you do kind of like the outside derivative first, keeping this the same, and then you multiply by the derivative of the x. Compare your answers with your group once you're done, see if you get the same thing.
Alright, I think I got it wrong.
Would you?
I got negative 11 over 2.
I'm going to take the derivative. Negative 1 half this way.
Yeah.
And it's x turns into 1, so it's small base, but like
Which x turns into 1? Which x turns into 1?
all the very bottom. Just turns
X to
into
the
1.
negative 1, right?
Oh, I forgot.
Negative 1 x to the negative second power. How does it turn into 1?
Let me see how you did yours.
No, it's the x on the very bottom.
Yeah. You put that on the JD, stop coloring in your water.
Way down.
Stop ruining my binder.
Not even a binder.
Derivative.
Stop it. If you don't shut your mouth, I swear I'm going to give you a dentist.
Alright, let's walk through it. Alright, so if I, just to make my life easier, I'm just going to rewrite this as 5x plus 2 to the negative first minus a half over x, right?
Yeah.
Okay, so now I'm going to L'Hopital. I love using his name as a verb. So here we go. Negative 1 times 5x plus 2 to the
Negative 2.
negative second minus, first times
5.
5 minus 0 all over 1. Alright, so now if I clean it up, I get negative 5 on top over 5x plus 2 squared on the bottom. I plug in my 0, and what do I get? Negative 5/4.
Not negative 11 over 2.
So can you not simplify the numerator before you do the derivative?
Can you,
Like, can you like,
can you go like from here to here?
like you do like 2 minus 5x minus 2 over 5x plus 2 times 2.
Times x.
Yeah.
Then you might as well just do the regular limit if you're going to do that.
Oh.
Yeah. Because that's, if you're going to do that, guys, if you're going to find an LCD and like multiply out the tops and move it to the bottom and all that, then you might as well just do the limit, right? So, because then, by then you've done the hard part, and then the easy part's just cleaning it up and plugging it in. Okay, which is fine, right? You can do that. You can still do all limits the old-fashioned way, and that's
I
fine.
don't remember how to do limits. What is
All
a
right.
limit?
Two more fun ones with regular numbers before we move into some infinity ones.
Bro, I'm too short. Bro, I'm too short. I guess you just never get a difference in that. Whoa, bro, why you gotta be so salty?
That's the word this year.
Salty?
Yes, I keep hearing people describing others
It's
as
like-
salty.
Do you know what it means?
Sandwich or salty?
My fifth period calls me salty all the time.
It's like when you're like,
So,
kind of like
I
bitter.
kind of, yes, this like, I have kind of a dry sarcasm to me in fifth period, so.
Bitter, angry, like
I don't know if I'm bitter.
peeved.
Wait, is
They
your
don't
have your
period
pencil,
AP
bro.
calculus?
Bro, don't
Yeah, but it's after lunch, so.
Like a rowdy bunch?
No, I just, I don't know.
I didn't want to.
It's a little different after lunch. So anyway, here we go. Oh, I'm sorry. Zoom in
That's
a
actually
little.
so funny, Miss Price.
All right.
I invented the word salty.
They did it.
You
You
did?
did, Mustafa.
Okay.
Mustafa's family actually works in the
I would not want to have to factor either of these. They don't group, right? So, if you were to try to factor them, what you'd have to do would be you'd have to like
Don't you draw the
synthetically
line?
divide out the 3 for both of them, right? Get what's left, factor out the x minus 3 that way, right, and then factor. Okay. Which would be alright, but I would rather not. So instead, if I plug in the 3, 27 minus 36 minus 9 plus 18, it is 0, right? If I plug it in here, 27 minus 9 minus 63 plus 45, take a guess what that is?
0.
It's 0, right? So if I plug in, I get 0 over 0, so yay, I can L'Hopital this. Everyone take a second and just do the derivative of the top and the bottom.
What if you use L'Hopital and it's not 0 over 0?
Ooh, that's going to bring us to our next example. You are like segueing into the next examples every time. It's good.
It's because we are on the same wavelength.
Mm-hmm.
This price.
Mm-hmm.
Stop. Bring me closer.
Bring me closer. Always bring me closer.
Bro, I don't have enough.
Use that upper body strength. Use your legs.
Alright, use my legs.
Poke them.
All
I'm on the
right.
inside though, so it's harder.
Now,
I go underneath.
quiet please.
Exactly.
As soon as you've L'Hopital, you have to plug in that number again. Because if you get a numeric answer, that's your limit. You have to stop, right? But if we plug in the 3 here, we get 27 minus 24 minus 3, which is 0 over 27 minus 6 minus 21, which is 0.
Keep
you
going!
still have a limit that is 0 over 0. Whenever you have a limit that is 0 over 0, you can use L'Hopital. So you can L'Hopital this thing again. What? So I want everyone to do another derivative of the top and the bottom.
This is insane. If it gets L'Hopital again, I'm gonna be so easy. I'm like, I don't know what'll happen.
Honestly, L'Hopital, I expect
I expect you to solve it.
2 derivatives, 1 problem.
Wow. Talk about killing 2 birds with 1 stone.
The salt loads on the room. NaCl.
Alright,
Why you be
you guys
so
okay with the derivative?
10.
Yeah? So now if we plug in the 3, we get 18 minus 8, which is 10. As soon as you get something that's not 0, you know you're not in L'Hopital world anymore. Over 18 minus 2, which is 16. So our answer,
5 over 8.
5/8. Alright, one more quick one of this nature before we move into the next type of L'Hopital problems. So suppose, make sure I'm not, let's see. Suppose I ask you the limit as x approaches 2 of 4x minus 8 over 3x minus 2. Everyone take a
You
second.
better check if it's L'Hopital. She might be trying to trick us. It's L'Hopital.
Can we trust Jacob? Can we
Yeah.
trust Jacob?
Oh no, guys, check it. Check it. I'd check it if I were you guys. Check it. She's trying to trick you. Look at that smile.
The smirk.
It's 0 over 4, guys.
Okay.
Check both of
You
them.
always check to make sure you can use L'Hopital before you use it, right?
Right.
So if we plug in the 2, we get
0.
over 4, which is 0, and that's just the limit, right? Okay, always plug in first. Always plug in first. All right, now we've got to move into another world of L'Hopital, the world of infinity. Because L'Hopital doesn't just work for 0 over 0, it also works for infinity over infinity. Which brings us to the world of horizontal asymptotes. Look at
Stop it, you're so smart.
Awesome.
I wish
But I
was
won't remember in May.
All right.
Trying. Senior year, December 15th, once I get accepted by UGA early action. I'm just gonna throw away all my books.
When we stop, if you throw away all your books, you're going to pay for them all, and you won't be able to get your diploma, and you won't graduate, and you won't go to UGA.
Wow.
Sorry. She will hunt you down and find you.
Actually,
for those
this
books.
price, you know how I lost the Phantom of the Opera? It's at Nutter's house. He won't give it back.
He threw it in my car and then I threw it away.
You throw away my
Somebody stole my PE book.
I didn't know what it was.
Did you really throw it away?
I had no idea what it was. It was just in my trunk one day. I was going to get my car and I was like, I don't know what this is, so I threw it away.
He threw away
It's
my
not
book.
very expensive to replace.
I know, but still. The principle though, Nutters threw away my book like that.
I'm sorry. Why'd you leave it in his car?
Well, we went to the car wash and the way my car's set up, like an SUV type. So
It doesn't make any sense.
I want him to clean everything, so I just put all my stuff in Nutter's car, who has like a trunk because he drives a sedan. So yeah.
Oh, I see what it's like. It's an open trunk.
Yeah.
And you got your belongings but missed that one?
I mean, yeah.
It sounds like a personal problem and stuff, but like,
Alright, so anyway, now, if we plug infinity in here, and you know what, guys, I'm sorry, this is why you write in pencil, I'm going to change the problem.
Gosh darn it.
Wait, we never finished that other pencil.
Okay,
Oh, she just switched around. I don't
Or
know
we
what
can
to
just
do.
change our signs.
you could, yes.
If you write them.
Okay, so if we plug infinity in, we get what over what? Infinity over
Negative.
negative infinity, right? It doesn't matter if the degree of the infinity is different. It's just infinity over infinity, right? Okay, and it doesn't matter if it's positive or negative. Infinity over infinity means you can use L'Hopital. So if you're looking at this and you're like, oh my goodness, I don't remember my horizontal asymptote rules. What am I going to do? Thank goodness I have L'Hopital. So what's the derivative of the top?
6x.
What's the derivative of the bottom?
Negative 2.
-2. So now, if I plug in the infinity, what do I get? Infinity over -2, which actually means it's going to be negative infinity, right? Signs do affect infinity.
How would you do that actually again?
Oh, horizontal asymptote rules. If the degree of the top is greater, that means there's no horizontal asymptote. Which
Yeah.
means it's going to either approach infinity or negative infinity, which means you plug your infinity in and check the signs. So you get a positive over negative, it's going to negative infinity.
But when we had to check it to see if we could, oh, we just checked it just cause it's our, we already knew. All right, I see what you did there.
Okay. All right. Let's do a negative infinity one.
That will make it so much harder.
It does. Now, this one, if you know your horizontal asymptote rules, this is a no-brainer, right? So if you know your horizontal asymptote rules, you can just write the answer and move on with your life, right? But say you just don't know your horizontal asymptote rules. It's the AP exam, you've just learned 863,000 bits of information, and one of the ones that actually filtered out of your brain was horizontal asymptote rules, right? So if they're gone and you're like, oh my gosh, what do I do? Thank goodness I know L'Hopital, right? Because if I plug my infinity in, I get infinity over infinity. Go ahead and L'Hopital this and see what happens.
Light on the hallways.
Those hooligans.
Those darn Japanese students.
Colonel Harvey.
I thought we were over this at the indeterminate.
Mr. Mormon.
I had this teacher as a French, his wife was a French teacher.
Okay, so what do you get for the derivative of the top? Over derivative of the bottom? Negative 4x, right? Okay, you have a couple routes you can go here. You could just cancel the x's, right? And then you have the limit of a constant, which is the constant, right? Or, say you didn't even know you could do that. You could L'Hopital it again, right? Because you still have infinity over infinity. And either way, you're going to get 6 over negative 4 or negative 3/2 as your answer. Okay? Alrighty. Let's do another horizontal asymptote. We all know what's coming next.
No. Oh, no horizontal asymptote?
No.
Denominator.
Curvy asymptote. A jump asymptote.
What are you talking about?
Jump discontinuity. Good job. Don't know what that is.
Getting concepts a little confused. Okay. All right, so if we plug in, we get infinity over infinity, right? Go ahead and L'Hopital this.
Are you sure you get infinity?
I am sure.
Alright.
Can we trust you?
Yeah, 3 over negative 4, right? 3 over negative 4 times
Negative 70 equals 1 over infinity.
0.
Now if I plug infinity in, I get 1 over what?
3 over positive.
3 over infinity.
3 over infinity, which in limit world, what is that equivalent to? What does this limit approach? 0. 3 over infinity, the limit is 0.
That's so cool.
Technically, it's not exactly 0, but the limit is 0.
So
Yes,
technically, you could just look at the limit and then realize that since the
bottom is bigger, yeah, it goes to 0.
Infinity.
Yeah, if you know your horizontal asymptote rules, then you don't have to do L'Hopital.
Infinity squared is bigger.
You never have to do L'Hopital. You can always just do the limit, right?
I feel like it's really good for like 0, 0 before horizontal asymptote kind of just
It takes a little longer.
gets in the way.
Yeah, gets in the way. You know where it'll be really helpful for you guys? When we get to trig limits.
Oh yeah.
Yeah. All right, one more last thing for the bell rings. Once in a while, you will hit a limit where L'Hopital applies but doesn't help you.
Like, what if you were to get non-zero over 2 with L'Hopital?
Then you're in vertical asymptote world and you just have to find the vertical asymptote.
Okay.
Yeah, that's just the old way. It doesn't help you with all limits, right? If you just get number over number, you just do regular limit. If you get not 0 over 0, that's vertical asymptote, and you just have to be able to do that. But it does help you with a lot of limits. All right. If we plug in here, we get what over what?
Probably like, I don't know.
I'm gonna go with positive infinity or positive infinity. Or no, I don't know.
We get infinity over infinity, right?
Yeah.
Okay. So, no, it's squared.
It's positive.
Oh, yeah.
Yeah.
Are you serious?
Okay. All right. So we get infinity over infinity, which means we can L'Hopital. I'm going to do this quickly. So we get on top 1/2 times 5x squared minus 3 to the negative 1/2 times what? 10x, chain rule, over 7. Cleaning it up, here's what we get. On top, I'm canceling the 1/2 and the 10 and getting a 5. So I have a 5x on top. On the bottom, I have 7 root 5x squared minus 3.
That still looks like a pain.
Now if I plug in, what do I have?
You got it again.
Infinity over infinity, right? So I L'Hopital again. So on top I have 5. On the bottom I have 7 times 1/2 times 5x squared minus 3 to the negative 1/2 times 10x. So I cancel the 1/2 and the 10 and I get a 5, and I'm going to cancel the 5 and the 5, and I end up with the limit as x approaches negative infinity of, this goes up now, root 5x squared minus 3, on the bottom, 7x.
I thought that was your phone.
Yeah. All right, take a look at the original problem and take a look at the new one.
Wow, you got rid of the 2.
I got rid of the 2, right? Have I helped myself really in any way at all?
A little bit.
Not at all.
I mean,
And
barely.
what'll happen is with every subsequent iteration of L'Hopital, you will just flip-flop back and forth between these two. It's a circular problem, it will never help you. So you have to just do this the old-fashioned way. All right, guys, have a wonderful day.